Hello everybody, Matt Davis here again with some more homework quiz help. This one is coming from section 7.4. Suppose that a random sample is going to be taken from a population that is normal with a mean of 287.55 and a standard deviation of 40.575. For a sample of size 23, find the probability that the sum of the x's is less than or equal to 6242 and round your answer using 4 decimal places. All right, we're going to make a couple changes here in the interest of giving help rather than answers. The first one is we're going to change our sample size. Instead of 23, we're going to go with 24. And while we're writing that down, it is the sample size, so let's label that as n too. And then our question we're going to change as well. So we're going to get rid of that one and change it to the probability that the sum of the x's is less than or equal to, let's go with 6319. So switching things up so I'm not giving you the answer, but the process is going to be the same. All right, so let's get started by kind of copying that question down, and then we're going to make some changes to it. But I'm going to write the sum of the x's, and I'm going to write less than or equal to, and I'm going to have the 6319. And you know, if you look at this, I've written it a little weird, so why is that? Well, I need to change this into a question that looks familiar to us. And we've been doing probability questions in Chapter 7 about p hat and x bar, and this is not about those, right? Or at least it doesn't appear to be at first. But if you take the left side and you divide that by n, then the sum of the x's divided by n is x bar. And on the other side, I'm going to divide by n as well, but instead of just writing the letter n, I'm going to put the value of n, which is 24. So it seems like a weird first step, but what it does is it changes it to a familiar setting for us. When we have the probability that the sum of the x's, we have the probability the sum of the x's over n. That is now a probability question about x bar, which is what we're used to doing in this section. So we're making the switch to make this look more familiar to us. On the other side, we just need to do the division. So I'm going to skip the calculator part in this and just write it down for you. But if you take 6319 and you divide that by 24, you get 263.29. So it's actually longer than that on the calculator. So I put 5 significant figures in this so that I'm hoping we'll get accuracy scores by having that much accuracy. When in doubt, put more, but I think 5 significant figures should be enough for us to get a z-score, which is typically 4 significant figures. All right, so we have a probability question about x bar, so we want to go after that. So the population is stated to be normal, and if you have a normal population, that means that x bar is also going to be normal, so we can use a normal curve to answer this probability question. If we're going to answer a probability question using a normal curve, we need the mean and standard deviation. Because our variable here is x bar, we need the mean and standard deviation of x bar. So mu of x bar is always equal to mu. And in this case, let's see if we can hunt that down. They told us that the population has a mean of 287.55. So that is mu because it's the population mean. And then again, the population has a standard deviation of this number. So that's going to be our sigma right there. So mu of x bar is equal to mu, which in this case is equal to 287.55. And sigma x bar, we can get that by using the formula sigma over root n. Sigma is the population standard deviation, that's the 40.575. And divide that by the square root of n, which in this case is 24. And then we need to know the value of that. So I'm going to go ahead and just give you that one too, because this is kind of a long problem. If you take the 40.575, divide that by the square root of 24, you get 8.2823. Remember, 5 significant figures are needed when we do standard deviations. So 1 in front of the decimal, 4 after. So we got 5 significant figures there. All right, so we know everything we need to now. Up at the top, we know that x bar is normal. We're being asked a probability question about x bar, so as long as we know the mean and standard deviation of that x bar, we can use a normal curve to answer that question. So that's what we're going to do. So let's draw a normal curve in here. In the center, we'll put the mean of the variable. The variable is x bar. The mean of x bar is 287.55. Just a reminder over here, the variable is x bar. And then we want the probability that x bar is less than or equal to 263.29. So 263.29 would be over here on the left. And we want less than or equal, so we would do the area to the left-hand side. So whatever that area is, that would be the answer to our probability question. So we can use NCDF to get that area, but first we need to know the z-score. So we're going to do the z-score for 263.29, which is our boundary. So from that, we'll subtract the mean, 287.55. And then divide that by our standard deviation. Now, when I say our standard deviation, that's the standard deviation of our variable. Our variable is x bar. Our variable is x bar. So we need the standard deviation of x bar when we do our z-score. So it's a common mistake there that, like in your head, you're saying you need to divide by the standard deviation. And then up higher, you've said the standard deviation is 40.575. So there's more than one standard deviation around. So we got to be careful. We're doing a probability question about x bar, so the z-score we need, the standard deviation we need, needs to be the standard deviation of x bar. All right, so what do we get for our z? I don't know. Let's go see on the calculator. So for z-scores, we need parentheses around the top, so we'll do open parentheses 263.29, which is our boundary, minus the mean, 287.55. Close the parentheses. Looks like I missed a number there, 287.55. Close the parentheses to make that subtraction happen first. Divide that by the standard deviation of x bar, which is 8.2823. So we get negative 2.929. Remember, round z-scores to exactly 3 decimal places. We'll stick with the 9 because it's followed by a 1. So, negative 2.929. So that's pretty far to the left with the z-score almost to negative 3. So that area should be very small. We can find that area by doing normal CDF of our left boundary, which we're going forever to the left there. So that's going to be negative infinity on the left. And our right-hand z-score boundary is negative 2.929. That area, whatever it is that area right here, which means it's also the probability we're looking for. So let's go to the calculator and calculate that area using normal CDF. So go to our distribution menu, normal CDF, left boundary negative infinity, so negative alpha I. That's only going to work if you've stored infinity into I. If you haven't done that yet, then make sure that you go back to the chapter 6 calculator videos, look for the video on storing infinity and get that done. And we have negative 2.929 is our other boundary. Missed a digit there again, 929. We were expecting a small area, so when I get 0.0017, that supports what I saw in my picture. All right, so let's write that down. So our normal CDF was 0.0017. So that's the answer that we're going to end up putting into active learning as the answer to the probability question. When you get that answer, you want to make sure that it matches your picture. So when we look at the picture, we do have a small amount of area. So getting a small number makes sense. Getting a negative number, by the way, does not make sense, and that's what would probably happen if you didn't have infinity stored to I. So always make sure that your picture and your answer are matching up with each other. All right, let's talk about places where this can go wrong. So where most people are getting stuck is they just don't know what to do with the question. So we see this initial question, we just kind of freeze up. So we need to turn that into something we recognize. So the key is if you take that sum of the x's, divide it by n, that gives you x bar, and now you're in a setting where we can go forward and make progress. The other key thing, which I already mentioned, is be careful that you're using the sigma x bar when you do your z-scores. If you use the sigma from the population, that's going to throw this way off. All right, hopefully somewhere in there you found what you needed to get through this one successfully. So head back to the quiz, and good luck as you give it another try.